Hello, everyone. I'm Stephen Say. I'm a software engineer from the specialty printing group at Zebra. Today, we are going to talk about how to use Link.OS SDK with React Native for Android and iOS. We will cover what is the Link.OS SDK and also give you a high-level view of the React Native and a walkthrough of using the how to use the native module demo. This is a typical workflow about any printing applications. You define your label, how your label should look like, and then you create your application, right? So we have a tool help you to create a label called Zebra Designer for developers. So that is covered by a separate talk. So we also have a SDK help you to create your own application. So the SDK is called Link.OS Multi-Platform SDK. So today we are going to focus on this SDK with React Native. Okay, let's jump into. So this is the overview of our SDK. This slide shows the major capabilities of our SDK. So we're not going to cover all those capabilities, in this talk, but I just want to highlight while we walk through this presentation, we use the printer discovery capability. We also used the printer connectivity capability in this presentation. And at high level, Link.OS SDK supports Android, iOS Xamarin, as well as PC Java, PC.NET, and .NET Xamarin. We also have SDKs support web sockets, the web services. So that's a high level. It's downloadable from our website. Let's see what the Link.OS SDK for Android and Java look like. Link.OS SDK for Android is written in Android Java, and for iOS is written in Objective-C. The deliverable of the library of this SDK in library format for Android, it is delivered as a jar file, and along with other open source jar files as well. For the iOS, it is delivered as a statical library, .a file, and also header files for all those APIs. So that's a very high level. And React Native is a cross-platform development framework for Android and iOS. It's created by Facebook. Now it's being widely used among the developers. So the React Native uses the JavaScript scripts plus the CSS for the UI design, and render the UI design in a complete native code, give the users a true native app experience. So that's a benefit of this framework. Now the question is how we are going to interact. There is a typo on this title. How we are going to interact between the React Native and the native Java and Objective-C. So that's something we are going to focus on today. So fortunately, the React Native provides a mechanism called a native module, allows us to expose the instance of Java or Objective-C classes to JavaScript as an object. And we can also expose those instances directly through the native application. So we can do this in Android or iOS through the either Android Studio or through the Xcode. So that's what we are going to walk through today. So let's say we are going to create an app across both Android and iOS platform. In this app, we will have one button, and click the button. We are going to search, discover the Bluetooth printers. And once the discovery finishes, we will get a list of those Bluetooth printers. And when we click on one of those Bluetooth printers, we will get a test label printed out. So that's very simple. So there are three aspects. First, we need to create a React Native project. To do that, we will show it later. And then we need to expose two methods First one is the printer discovery method to discover the Bluetooth printers. The second is to expose the method to write the content to the printer. So that's where we can print a test page. So those are two methods. So we need to expose them from the native code to JavaScript. So this is how we do that. You need to set up the React Native environment. And there are a lot of information on the React Native website and tell you how to set up the environment either for Windows, for Mac OS, or for Linux. So this walkthrough is based on the Mac OS. So I'm not going to cover the steps to set up the environment because it's already been well covered. So once you have the environment set up, we simply use this command line, npx react-native and init, and give the name of the project we want to create. So we give the name ZSDK RCT dev demo. So we run this command line on our Mac OS. So once the command line completes, you would see the project structure as shown in this screenshot. And so there are two distinct subfolders, Android and iOS, that represented Android native projects and iOS native projects. So those two projects, you can open them through the Android Studio or Xcode. Those are the places where you need to plug in our library. So I'm not going to go through the steps to add the libraries. You probably already knew that. But one thing I would like to mention, when you add the Java library to your when you add the Android library to your Android project through the Android Studio, please do not add the accompanying open source jar files, because those jar files are already included in your project through the creation by the React Native. So React Native automatically adds those jar files to your project automatically. You don't have to add them again, otherwise you would get errors. But for the iOS, you need to add both the static library as well as the header files to your project. So since we are going to use the Bluetooth, right, to discover the Bluetooth printers, for the Android, you need to give the permission. The access the fine location is required for the Bluetooth discovery on the Android 10 and above. So if you're running this application on Android 10 and Android 11, you need to add that permission. And for the iOS, you need to add the external accessory framework, as well as specify this port string com.zebra.raw port to the info.plist. So those screenshots shows where you can add those framework and also the protocol string in your project. So now we need to create, we need to expose those two methods as we mentioned before, right? So first of all, on the Android, we need to do a little bit more work. We create a class, ZSDK module class. You can give it any name for this class. We just happen to give it a name. The SDK represents our Zebra SDK module class. So this class has to implement the interface class from the React context based Java module class. And this is the interface class. And there is a method we need to override, the get name. That is the place we specify the name of the module. Because in the JavaScript, when we expose the module to JavaScript, we expose the module based on the name. So this name has to be specified. That's the name of the module. It's not the name of the class. So just to make it clear. So you can give any name to the class, but for the module name for here, we use ZSDK module as a name for this native module. And then you use the macro at React method to expose those discovery API as well as the write to Bluetooth API to the JavaScript through those two macros. So inside the implementation of those two methods, you simply call those native SDK APIs we provided through our library. So that's everything is done within this class. So now we go a little bit further about the discovery. As we said, we expose this method to the JavaScript, right? When you click on button, it will trigger this method to execute the discovery function in our SDK. But once discovery is complete, we need to return, or at least the response back to the JavaScript to what we have found, right? So we do that through the callback function. So when JavaScript call this API, it passes us a callback object. That object we will remember. We will pass that object along up to the point where we finish the discovery. Once we finish the discovery, we call this callback through the callback.invoke and pass whatever we have discovered as a JSON string back to the JavaScript. So that's a very common way to pass any value as a JSON string back to the JavaScript. So JavaScript can easily parse it and obtain this value. So that's how we do that in the Android. So once we have this class we just created to do the discovery, to do the print, then we need to expose this the instance of this class to the JavaScript. So this is what we do. We need to create a package, which implements the React package interface. So that's where we can plug in to instantiate the class we just created in this package. And then we need to instantiate this package itself, right? So there are two places. The first, we create this ZSDK module package, which implements the React package and overriding those methods, and instantiate the class we just created and add that into the module list, right? And return the module list from this method. And then we create a new file, it's a package file, right? Not new file. Yeah, we go to the package .java file, and we need to instantiate this package we just created. So there are two layers of instantiation. Then we instantiate the package we just created. So that's where on the second screenshot, that's how we instantiate this package. So this is for Java. Once we are done this and everything is exposed, is what we want to expose to the JavaScript. So there is one thing I want to remind when we use React method, that macro to expose method. So the method will exposed to the JavaScript asynchronously. So that's an advantage for us, because all the APIs in the Link.OS SDK are supposed to be used in a background thread, cannot be used in a UI thread. Because that macro at React method use the asynchronous mechanism, which means we don't have to open a separate thread in this ZSDK module.java class. So that makes it very convenient for us. So we don't have to worry about whether this method is going to be executed on UI thread or on a background thread, because that's macro takes care of this, because it uses the asynchronous mechanism. So that's for the Android. For the iOS, it's a lot simpler. We don't have to do the multiple jumps. We directly create a class. We call it RCT ZSDK module class, which implements the RTC bridge module interface. So here is a naming convention. The RCT is a kind of a prefix for the class name. That's a iOS naming convention. So the iOS knows the name of the module is the ZSDK module. So it will remove the RCT and find the module. So RCT is equivalent to NS for the next step, so other iOS naming convention. So here we don't have to specify explicitly the name of the module. We just use the module name by follow the naming convention by iOS. We can create a module with a module name ZSDK module. And then we need to expose this module. So we use a macro RCT export module and to expose this module to the JavaScript. Then we need to expose the methods, those two methods. So we use a separate macro RCT export underscore method to export to expose those two methods separately, to the JavaScript. So that's all done in one class, showing in this screenshots. So there are three screenshots shows a different portion of this file. So that's highlights where you do that, very easily. So once you are done that, it's done. So there is no additional hoops to jump for the iOS. So now let's work on the React Native part. On the React Native part, by default, we will have a app.js file created for you. So we just use that same file to create the UI. And first of all, we need to import the module, from the native. So we use we could create a separate ZSDK module.js. So that's where we import the ZSDK module from the native iOS or from the Android. So once we have that, then we should be able to call those methods which are already been exposed through the native code, the ZSDK Bluetooth, ZSDK printer discovery Bluetooth, and the ZSDK write Bluetooth, those two methods. So we can call it as if they are the JavaScript functions. But of course, one of them requires to pass in a callback function, and the write method takes two parameters. The first parameter is either the MAC address or the serial number of the printer, because on the Android you connect to the Bluetooth through the MAC address, but on the iOS you connect to the Bluetooth through the name of the Bluetooth device, so which is the serial number of the printer. So that's why in the screenshot in the middle, there are big box. It will demonstrate how you differentiate whether this code was made from the Android or from the iOS. So you can pass a different parameter accordingly to the native part. And for the discovery part, that's simple. You simply call the discover the printer. So that's all we need to do. So now I'm going to show there are two videos. The first one is a video from the Android device. The second one is from the iOS. To run the demo on the Android, you simply do that through the command line, illustrate here. From the iOS side, so you simply use the Xcode, open up the project's Xcode workspace file, and then recompile and click on run. Now it will download the app onto your iOS device and start to run. So let's watch a video to give you some idea how the application look like. So to click on the discover the Bluetooth printer and click on, so it sends right to the hello world on the label. So you click on second printer, it writes another hello world on another printer. So that's on the Android. On the iOS, it has the same look and feel as on the Android side. So the first button you click on, discover the printers, and then you click on the first printer, it will do a print, and the second do another print. So that's how it look like. So it's very simple. So the purpose of this talk is to show you how easy it is to use our Link.OS SDK with your React Native application. Very straightforward. In the end, there are some resources where you can download this demo app from the GitHub. And also there is a white paper about how to do that on a more detailed step by step. Yeah, you can find on our portal page. And if you have any further question, you can reach us through the social network channels or go to our website so we can connect. That's all for today's presentation. If you would like to join the live QA session, you can click on the separate link to join the live QA. Thank you.